Quick question. What does it mean to multiply? If I say 3 times 4, most of us picture 3 groups of 4. That's 12, right? Today we're going to talk about multiplying fractions, and here's the thing. The meaning doesn't change. We're still talking about groups, and we're still asking the same question. Let's find out what 1/2 times 3/4 means, actually, before we ever touch an algorithm, okay? So we're going to start with the story, because math should always make some kind of sense in the real world. Imagine you have a pizza, a square pizza, a rectangular pizza, and you have 3/4 of the pizza left. So I'm going to shade in 3. Oh, this marker is not great, but that's okay. Okay, so 3/4 of the pizza, that's what we have left. Okay? Your little sister comes home and you tell her she can have half of what's left. So the question is, how much of the whole pizza does she get? She gets half of 3/4. Okay? Notice the word of in mathematics. When we say of, as it pertains to fractions, that's multiplication. Half of 3/4 is half times 3/4. This is the key connection. Multiplication means of. It always has, even with whole numbers. 3 times 4 means 3 groups of 4. We're doing the same thing here. All right, now let's see the answer. So don't just trust the rule yet. Okay, we shaded 3 of them, that's our 3/4. Now we need half of that shaded area, because that's how much we're willing to give to our little sister, right? So we put a line down the half, that makes it, and then of the half that's remaining, we shade in, that's how much we're willing to give our sister, right there. 3/2 of the remaining. So we have 2 equal rows. My notes here, sorry. And the bottom half, okay, 2 rows times 4, 8 total pieces. Your sister is getting 1, 2, 3 out of 1, 2, 3, 4, 5, 6, 7, 8. So the answer should be 3/8. The picture shows us why the answer is 3/8 before we even use the algorithm. Look what just happened in the picture, okay? The top number, the numerator, okay? We got 3. Where did that come from? 1 times 3 equals, use a different color, not that blue that wasn't working for me before. 1 times 3 equals 3. 2 times 4 equals 8, right? So numerator, denominator. My dad taught me to remember that denominator is down. We multiplied, so now we just checked, right? We came up by multiplying across the shortcut. We got 3/8. Does that match what we came up with? It does. The algorithm isn't a mystery. It's just a shortcut for what the picture is already showing us. The numerators multiply because we're counting the shaded overlap pieces. The denominators multiply because we're counting the total of number of pieces it created. Now the rule makes sense and you'll never forget it. More notes. Let me give you one more way to see this, because the more ways you can picture an idea, the deeper you own it. You're training for a race. Your full training run is 3/4 of a mile. Today, you are only going to run half of your run. How far do you actually run? Half of 3/4 of a mile. Remember, of means we're multiplying. So 3/4 times a half. We could do it, that's the shortcut. But let's do it so you actually understand the concept. We have a number line. We have a quarter, a half, 3/4, and 1. 3/4 is our normal run, okay? We are doing half of our normal run. So somewhere around there, look about right. That's gonna be 3/8 of a mile. Same answer, different picture, different story. Let's do the shortcut to make sure it still matches, right? 3/4 of a mile times half. We're doing half of our run. 3 times 1 across equals 3. 4 times 2 across equals 8. 3/8. Same answer, different picture, different manipulative, right? Concrete example. Here's what I want you to remember from today. Multiplying fractions is not just top line times top line, bottom line times bottom line. That's the shortcut. Shortcuts are useful, but only if you know the why. When you know the why, you can catch your own mistakes because the answer will make sense to you. When you know the why, you can teach someone else because you can show them a picture or several pictures. When you know why, you can handle harder problems later, like multiplying mixed numbers or fraction algebra, because the meaning carries forward. In mathematics, knowing how is a start. Knowing why is the goal. The concept, not just the rote way of doing it. Okay, and then in closing, try this before you practice any more problems today. Draw the area model first, then use the shortcut. See if the two match. If you do, and they match, that's how you build real understanding.